In the previous video, what we did is we did a distribute list in order to be able to filter information that we're learning via our RIPng protocol. Now what I want to do is I want to use a method that's going to allow me to be able to recover should we lose an individual link. Remember, like I said in the previous presentation, if I lose a segment and I'm using a distribute list, and I'm filtering from a specific segment, if that's the only segment that remains that I can learn the prefix from, I'm never going to place that prefix in my routing table. Now that's going to be useful if I want to black hole traffic and prevent anything from being able to come in at all or on a neighbor by neighbor basis, but it doesn't help me in the event of, say, for instance, high availability. The best solution in order to be able to manipulate this process with regard to high availability is going to be focusing at metric manipulations. So if I want to manipulate the metric of a prefix, the go-to tool for me to be able to do that is going to be an offset list, irregardless if I'm running in IP version 4 or version 6. So let's go in and set up our scenario. We have an interface, and again, what we'll do is we'll use FC00 1/1/1/1/64. Now, what I want to do is I want to do my testing in the data center. So let's go to R22 and see if we can't trace route to that particular interface. Now, what we're going to see here is we're load sharing. We're load sharing across R3 and R2. R3 is taking us down to R12 all the way to R1. R2 is taking us to Cat1 all the way down to R1. So we're load sharing. Now, what I want to do is I do not want to use the link through R2 to reach this prefix. So I want to stop that unless this link goes down. So if this link goes down, I do want to failover. So what's happening is I do not want to learn it. Do not learn from R2 if R3 is up. Now the way to do that is going to be to alter the metric. So let's take a look at that metric. So first and foremost, what we'll do is let's do a show IPv6 route for FC00:1:1:1:1, and what we're going to see is notice my metric is 4. All right, now if I make the link from R2, so if I make R2 greater than 4, then what's going to happen is the system is going to say, I'm not going to place that in the routing table, but it will be left floating. It'll be left floating if I lose the better metric. So if I lose the 3 or lose the 4, then what's going to end up happening is that if I have a greater than 4, it will actually be used and be installed in the RIB in the absence of the more or of the better prefix or the better route. Now again, like I said, the tool to do this is going to be an offset list. Now what I'm going to do is I'm going to apply this offset list, and I'm going to do it, let's see, how best do I want to manipulate or to verify this? Well, we've already got our interface in place. Let me go ahead and just clear some of this stuff off here. Let's get some of this out of my way. All right. So where best to apply this? Well, let's see. Let's apply it on R2 itself and see what happens. So what I'm going to do is I'm going to state specifically here that I want to prefer the link to R3 to reach, let's just say everything. That'll be our first scenario. We'll say everything that we're learning, I want to prefer the link to R3 over R2. That's going to be the simplest configuration. So now what I'm going to do is on R2, I'm going to go to interface serial to 0. And what I'm going to do is I'm going to say that I want to do IPv6 RIP for the RIP process of RIPng, and I'm going to apply a metric offset. Now let's see what ends up happening now. Metric offset. Now how much am I going to offset it? Well, I'm going to say I'm going to add 2 to it. Now the point here is it doesn't give me, it's not like IPv4, it's not going to give me an in or an out option. It merely says to apply it. So let's take a look and see what's going to happen here. Will this change our metric? So let's go down to R22, show, let's say I'll just up arrow to it, show IP route. I'm looking for this specific network, and let's see what happens. So just to be safe, I'll clear IPv6 route star. Let me see something here. I just want to try RIPng, see if it takes it. I didn't think it would. I think in 12 you could clear based on the actual RIPng process. So clear IPv6 route star. Yep. Let's see what we got going on now. Well, it's still in our routing table. Well, let's do some debugging. Let's say debug IPv6 RIP. And let's see what's being advertised to us. Just wait a little while. See if we can get an interchange going on here. Yeah, this is where I wish I was better at telling jokes. I could keep you guys entertained, but you know, that's not my job description. No dancing, no singing, no jokes. I promise. Believe me, you're lucky I'm willing to do that. So, you all, let's see what information we have. So on R22, I want to start looking at information that we're receiving from serial 2/0. Okay, so let's see, this is going to be a message has been received, response received from R2. I know that because I specified the link layer or the link local address. And I can see that I'm learning prefixes, but the prefixes that I'm learning are just modified. They're just the straight values. So nothing is being changed. So what I did is I went to R2 and I applied the offset list to the interface S2/0, and it didn't do anything for me with regard to information that was being advertised to R22. Now let's make sure I didn't mess that up. Let's go through and take a look and make sure that I did not confuse anything. Let's see, do show run interface serial 2/0. And there's my offset list. Now let's take a look at what's happening here. Let's say show IPv6 interface. No, I don't want to do show IPv6 interface. I want to do show IPv6 route. And I want to look specifically for the prefix of 2001:222, or do I? Let's see here, 22, 22, 22. It's not going to be in my routing table. Yeah, it is. Well, look here. It's a metric of 3. Well, that's a loopback on R22 that's being advertised to R2. And it's only 1 hop away. But the system is telling me it's 3 hops away. Well, what's happening here is by virtue of the fact that I placed the configuration on R2, it's going to be prefixes that are being learned via RIPng that arrive on R2 that are going to be manipulated by the offset list. In IP version 4's RIP, version 2, what ended up happening, and for version 1, we could control the offset list in or out. Inside the context of RIP Next Generation, the offset list is only going to be effective on the device where it's applied, and it's only going to affect inbound or prefixes that I'm learning from my neighbors or from my RIP peers. So again, let's take a look at that. What I'll do is I'll remove this configuration on R2 now. So config T interface serial 2.0, and all I want to do is say no IPv6 RIP, RIPng metric offset. Now let's see what happens when I take a look at my show IP route for that prefix. Still 3, but notice my last update is a little bit out of there. Now it's 2. Well, I said it was 3 before, but the idea here is it's 2 as a direct result of the fact that it's a loopback. So it's 1 hop and then another hop to be able to hit that interface. So I misspoke there. You'll have to excuse me. So now what we want to do is let's go to R22 itself. Now what I want to do is I want to go to the interface connected to R2, interface serial 2/0. And I'm going to say IPv6 RIPng metric offset, and I'm going to add a value in here that's going to be pretty big. I'm going to say 10, but what I'm going to do right now is I'm just going to leave this the way it is. All right, so let's take a look at what we're learning now. Show IP v6 router RIP pipe include via FE80::2. Do show IPv6 route. Okay, well, I'm seeing my prefixes that I'm learning, but I don't see anything associated with any metrics. So do show IPv6 route. So let's take a look and see what we're going on here. So via 00, notice I'm learning prefixes. So for instance, the loopback of, see, there's me, that's directly connected. Let's pick one of these. Here we go. There's the one, the prefix that we were looking at specifically. And notice it's now listed as a 4. So what I'm going to do is I'm going to modify this behavior on this interface. What I'm going to do is I'm going to say I want to add 10 to it. So Control A, take out my remark. And now what we'll do is we'll enter the command. Do clear IP v6 route star. Show IP route FC00:1:1:1:1. IPv6. See how easy it is to make a mistake? Not enter the right command. Now if we notice, what's happening is I'm learning it via 4, a metric of 4 via serial 2/1. So let me trace route to it now. So trace route to IPv6 FC00:1:1:1:1, and we're going to go directly to R3. Now in the event, config T interface S21 shut, in the event that I lose that interface, show IP v6 route. Notice it's not in my routing table. Let's wait and see what happens. Show IP v6 route. FC111, notice it's now a prefix of 13. So now let's look at it specifically. Now it's in my routing table, and let's trace route it, and what we're going to do is we're going to find out it's going to traverse R2. So what we just did is we used offset lists to be able to manipulate the metric associated with the prefixes that we're learning via RIPng. The important component is that RIPng uses the offset metric on an inbound, not a outbound or inbound configuration in the way that RIP version 2 or version 1 does. The main goal here is to understand that if we want to manipulate it, we need to be able to do it on the actual device where we want the manipulation to take place. So with that being said, I'll see you guys in the next video, and like I said, you may want to just get up and stretch your legs. I know we've been talking about RIPng and RIP version 2 for a long time, but like I said, I want to cover every topic that I think you guys are going to have a high probability of seeing in the context of the lab. So I'll see you guys in the next presentation. Bye-bye.